Hi, welcome back to another episode of Algebra in Words. This video is a continuation of the last video where we're discussing systems of two linear inequalities. In the last video, I gave an overview of the procedure that we use to do it, and I also did an example. In this video, I have another example, and we'll probably do one or two more. So anyway, let's get started. To start, we have our two linear inequalities. Take notice of the inequalities. They're inclusive because these are both greater than or equal to. The first step here is to convert each of these inequalities into equations just by putting equals in for each of these. So I'm going to do that here, and we have negative x plus y equals 3. And down here, so we have a little room, 2x minus y equals negative 2. So that step's done. The next step is we want to graph them. Again, I went over graphing linear equations in previous videos. If you need extra help, but assuming you know how to do it, in this case, we're going to convert each of these into slope-intercept form and then use those forms to graph. So for this one, let's add x to both sides. And then we have y equals x plus 3. And just so we can see it, I put a box around that. We have slope-intercept form, y equals x plus 3. And now let's simplify the one in the bottom. Let's subtract 2x from both sides. And that gives us negative y equals negative 2x minus 2. And let's divide all terms by negative 1 to get rid of the negative, which leaves us with y equals 2x plus 2. Next would be to graph them. I'm going to graph the top one first, and I'm going to use brown for that one. I'm going to do it over here actually. And the y-intercept is 3, so let's go up 3. And the slope is 1 over 1. So we're going to start at the y-intercept, and we're going to go up 1 to the right 1. And up 1 to the right 1. And let's go back to the y-intercept and do the reverse. Down 1, left 1. Down 1, left 1. And now let's draw the line. Do we want that line solid or dotted? We want it solid because these are inclusive inequalities. All right? And let's go to the next equation, which is this one. I'm going to use red for that. And again, starting with the y-intercept 2, let's go to here, 2. And the slope is 2 over 1. So we're going to go up 2 to the right 1. Up 2 to the right 1. And let's do the reverse. Down 2 to the left 1. And that should be good. And let's draw the line through that. Again, it's a solid line because these are inclusive. It's an inclusive inequality symbol. All right, so we have both lines graphed. The next step is to shade, and to do that, we want to determine a test point. Can we use test point 0, 0 here? I would say yes, because neither line goes through 0, 0, so we can use that as a test point. I'm going to do the test equations over here. So test, let's just write test 0, 0. And so 0 is going to go in for x, and 0 in for y, greater than or equal to 3. And simplify, we get 0 is greater than or equal to 3. Is that true or false? Is 0 greater than 3? It's false. So coming over here, what does false mean? Well, if the test point is over here, we're going to shade the opposite side of the test point from the line. So that would mean shading up here. And now let's do the same for the other line. We're going to do 2 times 0 in for x minus 0 in for y greater than or equal to -2. Simplify everything. 2 times 0 is 0, minus 0 is going to be 0, greater than or equal to -2. Is 0 greater than or equal to -2? That would be true. So what does true mean? If this is our line, we're going to shade the side with the test point, which would be over here. Okay, now we're ready to look at the graph to find the overlapping shaded region. And it might be hard to see, but if you look real close, we have a region right here. And that's the region where the brown overlaps with the shaded red, and that's the solution to the problem. Right there, the overlapping shaded region. We graphed both of our lines, they're correct. Both lines are solid because these are inclusive symbols, and that's it. So I'm going to pause this and put another one up on the board to take a look. Okay, we're back, and I put another problem on the board. Let's take a look. I tried to choose a problem that looks a little bit different. Notice that the first inequality is a one variable inequality. Okay, x is greater than or equal to 2. Think about that a second. Do you think that's going to generate a vertical or a horizontal line? It's going to generate a vertical line. We'll graph that in a second. Let's look at the other one. 3y is less than x minus 3. Okay, what are some details that stand out about that? Well, first of all, this is an inclusive symbol. This is a non-inclusive symbol. So in this case, they're both different. So we'll graph them accordingly. And also, if you notice that in this one, we kind of already have the term with y on the left. So when we convert this into an equation, it'll just be one less step into converting it into a slope-intercept form. Anyway, we'll do that in a second. But first, in regards to this, usually the first step is to convert the equation into slope-intercept form if possible. But do we need to do that here? No, the equation is already done. It's going to be, we know it's going to be a vertical line, and so there's nothing we can do except we can make it an equation x equals 2. And we'll graph that in the next step, 2 steps later. And then the same for this one, make it an equation 3y equals x minus 3. But again, we want it in complete slope-intercept form, and that means getting y completely alone. So to accomplish that, we're going to divide all terms by coefficient 3, and then that cancels these out to leave y equals 1/3 x. You could also leave it x over 3 if you like. It's the same thing. Minus 3 over 3 reduces to 1. So the next step would then be to graph. And I'm going to graph them over here. Let's start with this one. X equals 2. Start at the origin, count over 1, 2 units. That's x equals 2, and it's going to be a vertical line. Should that be dotted or solid? It should be solid because this is an inclusive symbol. Let's look at the next one. Y equals 1/3 x minus 1. Okay, so we'll start at the origin and go down 1 to the y-intercept. That would be here. And using the slope, we're going to go up 1 and to the right 3. Up 1 and to the right 3. And do it again. Up 1 and to the right 3. And we could do the reverse. Down 1 to the left 3. And that gives us a few points so that we can make a good line. Should this line be solid or dotted? And I hope you say dotted because it's non-inclusive. So let's just make little erase marks to show that the red solid line is going to be dotted. All right, the next would be the test point. That's the origin. I know there's some marker there, but that's just from when we were making the lines to use the slope to make the line. But no, neither of these lines goes through the origin 0, 0. So I would use test point 0, 0 once again for this. So let's say test 0, 0. I always recommend that you write out the test point on paper. And now we're going to take that and substitute it up into both original inequalities and see what we get so that we can shade. Into the top, 0 in for x, greater than or equal to 2. Is that statement true or false? It's false. So when it comes to shading, do we shade the side with the test point or away from the test point? Since it's false, away from the test point. And what about the other one? Let's use a different color. And we're going to put 0 in for y, less than 0 in for x, and minus 3. This becomes 0. This gets, we don't have to write that, and we get negative 3. And is 0 less than negative 3? No, 0 is greater than or less than 3. So this is false. And let's come to our red line. And since this is false, do we shade the side with the test point or away from the test point? False means away from the test point. All right, there we go. So now the next thing is to look for the overlapping shaded region. And if you notice that the shaded region of brown lines are here, and the shaded region for red lines are here, so the overlapping shaded region is going to fall in here. And that's pretty much the end of the problem. We highlight the overlapping shaded region. We make sure that your teacher knows that the red line or the line representing this inequality is dotted because it's a non-inclusive symbol. And that's the answer to the problem. I'm going to pause this and put up another one. Welcome back, and notice that I have another problem on the board. In this example, there are 3 inequalities. So we're going to take a look at that. And we're going to follow all the same steps. It's just that there's a third inequality, so it'll make a third graph. Let's get started. Starting at the top, let's just make all of these equations. Y equals negative 3x minus 5. Y equals 4. And negative 2x plus y equals 0. All right, so let's look at the top, and next step is to graph. Luckily, they saved us a step because it's already in slope-intercept form, so there's no extra work to convert on that one. Next, we have y equals 4. Also, one variable in that, no more work that we need to do to convert that. Also, what is this going to be? It will be a horizontal line. We'll do that in a second. And finally, we have this one. Let's convert this into slope-intercept form. I'm going to add 2x from both sides, which is going to make y equals 2x, and that's it. All right, so we have this equation, we have this equation, and this equation, and now the next step is to graph all 3. Let's see. Let's do that here. And let's start with the top one. I'm going to use brown for that. So starting with the y-intercept, minus 5. Down 1, 2, 3, 4, 5. And the slope is negative 3 or negative 3 over 1. So we could go down 3 and to the right 1. That would give us a point here. But since that's kind of bringing us off the page, remember we can apply the negative sign to the opposite part of the fraction. For example, instead of negative 3 over positive 1, we could do positive 3 over negative 1. So starting back at the y-intercept, negative 5, let's go up 3, positive up 3, and to the left 1, representing minus 1, and up 3, and to the left 1. So now we have a good bunch of points, and let's draw the line for that. Inclusive or non-inclusive? Non-inclusive, so let's make that dotted. And to save a little space, I'm just going to erase the lines that we used with the slope to clean it up a little bit. And this is what we're going to get. And next, let's graph y equals 4. Remember, when you have y equals a number, that's going to be a horizontal line. So let's find y equals 4, up 1, 2, 3, 4, and make a horizontal line. This will be non-inclusive, so let's make that dotted. And last, we have this equation. I'll use green for that. And what's the y-intercept here? It's actually 0. So we're going to start at 0 and use the slope 2 over 1. So starting here, 2 over 1, up 2, and to the right 1. And up 2, and to the right 1. And let's draw the line for that. And let's take it from there. Next is going to be shading. So let's find a test point. Now, what about 0, 0? Now, let's talk about that a second. Clearly, 0, 0 is lying on this line. So, here's the thing. We can't use the test point 0, 0 for this equation. We could use it for the other two equations if we wanted, just to be clear on that. But basically, just for consistency, let's choose a test point in which none of the lies lie on. So looking at this, I'm thinking maybe right here. I'm thinking 1, 0. So let's do test point 1, 0, just to be consistent. We're going to put 1 and 0 into the top inequality and see what we get. So 0 in for y is greater than negative 3 times 1 in for x minus 5. That's just the minus 5. So we get 0 is greater than minus 3 minus 5, and to just simplify that, 0 is greater than negative 8. Is that true or false? Is 0 greater than negative 8? It's true. So what does that mean? If our test point is here, and this is the line for the equation, it's true. So we're going to shade the side with the test point. So that would be over here. And let's look at the next one. I'm going to change colors. And we have y. Y is less than 4. So put 0 in for, 0 in for y. And is 0 less than 4? Is that true? It's true. So what does that mean? If this is the line, then we're going to shade the side with the point. So that would be down here. And that brings us to the last line, which would be this one. Now, before we go on, remember this is non-inclusive. Let's make sure that we make this line dotted so it's correct. And now we're going to take the test point 10 and put it into this. I'm going to squeeze it in over here. So -2 times 1 in for x plus 0 in for y is greater than 0. So when we simplify, we get -2 is greater than 0. Is that true or false? It's false. So what does that mean? With regards to the green line, we're going to shade away from the test point. So that would be in this direction. And I think that's clear enough. All right, so we're almost done. Now that we have all of the inequalities graphed and shaded, let's take a look at the graph to see if we can identify an overlapping shaded region for 3 inequalities in this case. Okay, so if you look real close, the overlapping shaded region happens actually right in this triangle. And if you want to use a marker to just kind of highlight that, it might look like this. Make sure that you still accentuate the fact that all 3 of these are non-inclusive, so they all have dotted lines, so make sure that your teacher can see that on your paper. Make sure that you know that. And basically that's it. Some test questions may ask you for the vertices or the points of an enclosed shaded region. So if that's the case, then make sure that you graph this neatly so that you can see exactly where the points are. And I put the points in for you if you wanted to see. These are enclosed by the vertices -3, 4, 2, 4, and -1, -2. So that concludes these example problems for systems of 2 linear, or it could be more linear, inequalities. The procedure is all the same. Thanks for watching. If you found this helpful, please give a thumbs up. Please share with your friends. Please subscribe to the channel so that you can be alerted when new videos come out. And also, please feel free to leave feedback in the comment section. Also, keep a lookout for other related videos in Facebook and Instagram. Thanks for watching, and I'll see you next time.